Everyone, today we're going to be talking about circles and central angles, and specifically by the end of the lesson we're going to be able to identify the parts of a circle and find the central angles in the circle. So we're going to begin with 3 vocabulary words. The first word is radius, and a radius is a line segment that has one endpoint at the center of the circle and the other endpoint on the circle. Some people describe the radius as going halfway across the circle. The important part is that one endpoint is on the center and one endpoint is on the circle. A diameter is going all the way across the circle and through the center. So you notice that the length of the diameter is twice the length of the radius. Both endpoints are on the circle. And again, the diameter has to go through the center. A chord has just 2 endpoints on the circle. It doesn't have to go through the center, but I want you to be thinking about, could a chord go through the center in order to fall under that definition that's written there? So, for example, could a diameter be classified as a chord? So be thinking about that because that's actually going to be one of your quiz questions at the end. All right, so we're going to practice identifying some radii. I'll let you know that radii is the plural form of the word radius. We're going to find diameters and then we're going to find chords. So first we'll start with a radius. So there's actually 3 different radii on this picture. So can you find them? The most obvious one I think is probably DC. Remember that a radius goes halfway across the circle. So you can call that DC or CD. Notice that when you label or when you name a line segment, you should use the 2 endpoints as the name. A lot of times we list them in alphabetical order. You don't have to, but that's what most people do. Okay, and then we actually have 2 other examples of a radius on here. We have BD or DB, and we have DE or ED. Those are all called a radius. Okay, so now we want a diameter, and remember a diameter goes all the way through the circle and through the center and has endpoints on the edge of the circle. So BE would be a diameter. And then a chord, remember, doesn't have to go through the center, and so a chord would be something like AF. So there's our examples for this specific circle. So now I'd like you to do this one with me, and I want you to point to the answers as we go through it. So first I want you to point to a radius, and again, there's actually 3 examples on this one. So be pointing to a radius, and I'm going to show you 3 different answers. So look at these line segments that I've listed, X, Z, R, Z, and WZ. So hopefully you're pointing at one of these 3 radii. Okay. And now let's try to find a diameter. Remember, a diameter goes all the way through, all the way across and through the center. So be pointing to a diameter, and I'm going to label one. Hopefully you're pointing here, and if you were to name that diameter, it would be XR or RX. You wouldn't want to call it XZ or ZR because that doesn't use the endpoints of the diameter. Okay, and then lastly as a chord. So I want you to be pointing to a chord before I write where it is. So hopefully you're pointing at YS or SY, and that's our chord. That's actually not the only example of a chord on here, but I want you to be thinking about that. Okay, and then lastly we have these practice problems. This one looks a little bit different, but you can still find a radius, you can find a diameter, and you can find a chord. So I want you to, on a piece of paper right now, if you don't have one, pause the recording and go get a piece of paper. And I want you to write down an answer for each one of these vocabulary words. And I want you to use the correct notation. I want you to use the line segment symbol above the two letters. And use capital letters because that's the letters, those are the types of letters that are used. So be very precise when doing these problems. And when you're ready, unpause the recording to check your answer. Okay, so hopefully you have tried out these problems and you can double check and see if your answer is up here. Notice that there's only really one place that you can see a diameter. There's only one line segment that qualifies as a diameter. All right, so let's move on to part 2 of our lesson, which is about angles and central angles. So an angle is formed when two rays or line segments are connected at a single point called the vertex. The difference in the direction of two rays determines the angle's measure in degrees. So I've got a lot of pictures up here to show you some different angles. Every one of these angles has a different measurement. Well, we've got two different 90-degree angles on here, but they look the same. So the way that the two directions of the rays go determines the degree of measurement for the angle. Okay, so a lot of times people will use what's called a protractor. This is called a protractor, and that measures how wide or narrow an angle is. So a 90-degree angle is a perfect corner. Like if you look at a piece of paper, the corner of the piece of paper is a 90-degree angle. Half of that angle, if you folded it right in half on that corner, it would be a 45-degree angle because that's half of 90 degrees. If you double the 90-degree angle, it goes all the way flat and it's 180 degrees. If you go all the way around in a circle, that's 360 degrees. So we're going to talk more about that in a second. So a central angle is an angle whose vertex, notice the point P is the vertex of this angle. That vertex must be at the center of a circle, and then the angle will be called a central angle. This angle is called angle APB, or you could call it angle BPA. All right, an arc is part of a circle connecting 2 points of the circle. So the arc for this is actually just this part. It's curved, it's part of the edge of the circle, and it stops at A and B. So the way that you would write that would be arc AB with a curved line like that. A central angle is congruent or equal to its intercepting arc. So we measure arcs with degrees just like we do with angles. So the measurement of the arc for the central angle is the same number of degrees as for the central angle itself. Hopefully that's making sense. Okay, so now we're going to talk a little more about that arc and the central angle. So the region that is created by that central angle or by the two radii and an arc is called a sector. So that's the region of the circle created there. Again, like I was saying before, there are 360 degrees in a full circle. So if you go all the way around the circle, that's 360 degrees. Half of a circle is 180 degrees. So let's practice finding some measures of angles. So let's do number 1 together, COD. So it helps to kind of draw it out yourself with your finger or your pencil. COD. Go in the order of the letters. So COD. We want the measure of this angle, and there's no label right there. But we do know that the intercepting arc for that central angle is 58 degrees. And we know that the central angle is congruent to the measure of the intercepting arc. So we can say that it just is 58 degrees. So the measurement of angle COD is 58 degrees. Okay, now let's try BOA. So I'm going to erase some of my work here. BOA. Now this could be tricky here. There's nothing written. We want the measure of this angle. And there's nothing really written there. There is a 32 next to it. And what you might notice is that if you include 32, then if you go all the way across from C to A, the whole amount is a half circle, which is 180 degrees. So in other words, the measure we're looking for, the blue angle that I have highlighted there, plus the 32 degrees is going to equal the full half circle. So the blue angle plus the pink angle equals the half circle 180 degrees. So if I wanted to find just BOA, or the blue angle, then I would need to do 180 minus the 32, and that would give me the missing piece. So I'm going to go ahead and do that subtraction really quick. It's going to involve a little bit of borrowing, and I'm going to have 8, 4, and 1. So the measurement of angle BOA is 148 degrees. Okay, lastly, let's do DOA. DOA, let's go ahead and highlight that one. So again, go in the order of the way that the letters are. So D to O and then to A. This one is kind of similar to the last one. It's not the same though. It's not the same number. You can't just look at it and think, oh, maybe it looks the same. Remember that COD was 58 degrees right here. But we want this angle right here. Let's make that look more like an 8. 58 degrees. Okay. So if we kind of look again, going on that COA line, that's a half circle. So we know that the 58 plus the yellow angle is going to equal 180 degrees. So I'm going to write that out here. 58 plus our missing yellow angle, the one that we want, is going to equal 180 degrees. Which means if I do 180 minus 58, that's going to give me the missing piece. So again, we need to do a little borrowing. 10 minus 8 is 2. 7 minus 5 is 2. And we're left with 122 degrees. And that is the measure of that yellow angle, the missing angle right here. 122 degrees. Okay, so some of those can be a little bit tricky, and it just takes practice of seeing those half circles and finding out how to find that missing piece. Okay, so now we're going to look at sectors. So you have to keep in mind that a full circle is 360 degrees. That's one of the most important facts to help you with these types of problems. So this is a pie graph of how someone's time is spent in a week. So we've got time at work being 48%, time at home being 40%, and time spent out being 12%. So the first thing is to change those percents into decimals. So I'm going to go ahead and do that. Remember, now we need to remind ourselves of the direction. Sometimes I forget just as much as you do. It says to find the central angle. Okay, so they want to know how big of an angle is each angle. And you can't say it's 40% because that's not an angle. That's not a measurement in degrees. We need the measurement in degrees. So if you know that the whole entire circle is 360 degrees, and you know that, say, the red sector is 40% of that, then you just need to find 40% of 360 degrees. So the first thing we're going to do is change our percents into decimals and then multiply those decimals by 360 degrees. So here's an example. For time at home, okay, we're going to do that one in red. So let's do that. So we know that time at home is 40%, and we got to change that 40% to a decimal. So we're going to do 0.40, and then we're going to multiply it by our 360 degrees, because that's the total amount of degrees in the entire circle. And if I do that, you might want to get out a calculator and double check my work, but I think it will become 144 degrees. So this angle right here is 144 degrees. Okay, now let's try the time out. Time out is 12%. Well, as a decimal, 12% is 0.12. I'm going to multiply it by 360 degrees because that's how many degrees are in the whole circle. And double check my math with your calculator or on your own paper, but we should be getting 43.2 degrees. Okay, last one. Oops. Let's go ahead and get out a blue. Okay, 48%. Oh, I should have labeled that on my circle. Whoops. 43.2 degrees for that one. Then my last one should be 48% time at work. So 48% as a decimal is 0.48. I'm multiplying it by the total number of degrees in the circle. And again, check my math, make sure I'm right, but this one should be 172.8 degrees. So this sector here came out to 172.8 degrees. Now, if we did everything correctly, it should all three of our answers should add up to 360 degrees, right? Because we should be getting the total number of degrees for the circle because we've done all three sectors. So I'm just going to go ahead and check my math here. This is one way to check your answer. 8 plus 2 is 10. And 1 plus 2 is 3, plus 3 is 6, plus 4 is another 10. And then we've got 8, 9, 16, and 1, 2, 3, 360 degrees for the total circle. So we must have done something right. Okay, so now I'm going to go ahead and switch to the next section. This is another similar problem, and what I'd like you to do with this problem is try it out on your own. You might even pause the recording right now and do it. And then I want you to double check your answers and see if you can get it right. If you're not sure about this, try a couple of them out and check your answers, and then send me a message if you missed one or two of them, and we can maybe go over it together. Okay, so I'm going to give you a minute to pause the recording and either draw it out on your paper so you can work on it, or try it out right now before finishing up the recording, and then unpause when you're ready to see the answers. Okay, so hopefully you've tried out some of these, or you have it written down so you can practice it. Here are the answers. You can write them down. Double check them with your own work. Okay, and then that is it for today's lesson. Thank you so much for watching. And here is our exit ticket, or the quiz for the end of this session. Notice that number 3 has a picture with it. So please open up a message or an email to me, and then type your answers to these questions and send them to me, and you'll earn your points for this week's synchronous session.